Now for this final step, the permutation of all the layers, we only have one algorithm. And for this we have to give credit to Stefan Pochmann for sharing it with us on his website. And he found this easy 2-gen algorithm that what it does is it switches these two edges and these two corners on the top layer. And as long as you do it in sets of 2, the bottom layer is undisturbed. And so as an example of this, the entire cube is solved, and this is how it permutes all the pieces. So the permutation algorithm is dash -3 dash 3 dash -3 dash 3 dash. So as you can see, moved these two edges and these two corners, but the bottom layer is unpermuted. So to fix this, we do it again. And to show how flexible this is, we're just going to offset it just by a little bit. Now it'll move these two edges and it'll switch these two corners. Using the algorithm, it's dash -3 dash 3 dash -3 dash 3 dash. And so from the solved state, the entire bottom layer has been undisturbed, while on the top layer we've essentially done a 3-cycle with these 3 edges. This edge goes there, and that comes down. There's a lot of flexibility behind this algorithm. Now while we just did a 3-cycle with the edges, we can also do a 3-cycle with the corners. Now between these two edges, repermuting the edges, moving the corners. But naturally, we're not often going to arrive at a spot where one layer is already perfectly oriented, which brings us back to why I always solve with the green, why I always orient all the green edges on the top layer rather than the bottom layer where they belong. This is because when you get to this step, you can permute the entire last layer and then put it on the bottom and get it out of your way. So a simple step for permuting, because we don't have a 3-cycle, or an apparent 3-cycle, corners or with the edges, or any other pattern thereof. What we can do is we just have to start pairing up colors instead, and eventually we get a shape, or we get a recognizable pattern. Now, in a speed solve, you would not necessarily recognize that if you switch these two, you'd have a 3-cycle with the edges. But in a speed solve, rather, look for pairing up the colors that are most solid. So right now, we could either bring this red-blue with the rest of the reds, or we could put this yellow into this little slot and then put the corner back in a second permutation. But we're going to go with the red one just because it's easiest and there's most colors paired up here. So now we just have a 3-cycle, which makes it rather easy for this layer. And so, the entire green layer is permuted. But there's still a problem with it, is that it's on the wrong side. So we need to put it on the bottom. To do this, I'm going to offset it a little bit. Dash 6 6 dash. That puts the white on the top for us to permute entirely. And so again, I just want to look for connecting the colors together. In a speed solve again, and even right now I don't recognize that I actually have a 3-cycle of edges, or corners. But the blue can go with the rest of the blue. Now we have the simple pattern where these two have to be solved with these two. And it's solved now, essentially, except for the middle layer. This happens a lot actually, where the middle layer is misaligned, but the other two layers are completely good. To fix this, what we want to do is dash 6 dash 6 dash 6. So that's almost all of how you permute and solve a square one. But there's one last thing that no one likes about it. We have parity! It's actually almost exactly like this pattern right here, where just two edges are mixed up and everything else is solved. So, same thing right here, we just have two edges mixed up. Alternatively, we can have two edges across from each other, but we'll discuss how to fix the across from each other in just a second. So you go like this. Unfortunately, there's no easy way around it. You just have to memorize this really long algorithm. But unlike a 4x4, you can remember it easily by recognizing the shape that the square one is in. So here's your algorithm, and it's long. Dash -3 dash 3 dash -3 dash 3 dash 2 dash 2 dash -2 dash 4 dash -2 dash 2 dash -1 4 dash -3 dash. That fixes parity. Of course, it does misalign the middle layer, but we already know that's easily fixable with dash 6 dash 6 dash 6. Okay, so that's how to solve the parity when they're in an L shape like this. If you arrive to a case where you have the permutation pattern on the top, but it's already solved on the bottom, and as you know, you have to have an even number of those permutations to solve the top layer, you don't actually have a parity. What you can do instead, just turn it aside, just do a -3, so all these solid colors are facing you. Do the permutation algorithm. And then -3, and you have the pattern on the top and the proper pattern on the bottom that'll solve the cube. If you ever get a parity while solving the green layer when it's on the top, you also might have a parity on the bottom layer. You can solve both these parities by simply sending them to the other layer and solving both, rather than doing a parity on the top, getting to the bottom and finding out you have a second parity, which you can then solve again. But you can fix them both by doing this. Do 1 dash 1 -1 dash 1 6 or 5 or -5 dash -1 -1 dash 1. So that fixed the parity on the top. And if there was a parity on the bottom, it fixed that one too. Or if there's only one parity, it just moved it to the bottom, and we can solve it when the cube's almost done. So if you have a parity where they're facing across from each other, what you can do is you can just do the parity algorithm, and you can turn it into a 3-cycle. So that parity algorithm. So after fixing the parity, we just have a 3-cycle on the top, and it's already entirely solved on the bottom. So by doing the permutation algorithm, we practically solve it. And so there we go. That is how to solve a square one. If you have any questions, feel free to message me. I will answer them. Till next time.